Welcome to my Lab 8 demonstration for the full-stack cloud-native development course. In this video, I will show the deployment of the Algonquin Pet Store microservices architecture on Azure Kubernetes Service. I will demonstrate that the application is fully running, that orders are being generated and processed, and then I will present the improvements required in Task 2, the MongoDB ReplicaSet and persistent RabbitMQ configuration. To begin, I display all the Kubernetes pods running in my AKS cluster. All microservices are successfully deployed. The order service, product service, makeline-service, the store admin and storefront web applications, and the two simulation services, the virtual customer and the virtual worker. We can also see the MongoDB stateful set with 3 replicas, and the RabbitMQ stateful set with its persistent volume. All pods are in a running state, which confirms the deployment is healthy. Then I show the list of services. The storefront and store admin services are exposed using external load balancer IPs, while the internal microservices use cluster IE. This setup ensures the architecture is reachable both externally and internally as required. Next, I open the store admin portal using its load balancer IP. Inside the admin dashboard we can see a large list of orders. These orders come entirely from the virtual customer workload, which simulates real incoming traffic. I then show the logs of the virtual customer deployment. The virtual customer automatically sends new orders to the order service at regular intervals. The logs show successful HTTP 201 created responses, which confirms that the order service is receiving and processing the requests correctly. After that, I show the logs of the virtual worker. This service consumes messages from RabbitMQ and updates the orders as they move through the workflow. Seeing the logs update in real time demonstrates that RabbitMQ is working, messages are being consumed, and the entire order pipeline is functioning properly. Now, I will demonstrate the improvements from Task 2, beginning with the MongoDB high availability configuration. Inside the primary MongoDB pod, I check the ReplicaSet status. The output shows 1 primary node and 2 secondary nodes. This confirms that MongoDB is configured as a proper 3-node replica set, providing replication and fault tolerance. I also display the contents of the ordered database. The orders generated by the virtual customer are stored correctly, and the document count increases as new orders arrive. This proves that the database is persistent, highly available, and synchronized across all replicas. Next, I show the persistent volume used by RabbitMQ. RabbitMQ is deployed as a stateful set with its own persistent volume claim. The volume is in a bound state, which means message data is stored outside the container file system. If the RabbitMQ pod restarts or moves to another node, the data remains intact. This satisfies the Task 2 requirement of enabling durable message storage so that messages do not disappear when a pod restarts. I then show all stateful sets in the cluster. We can see the MongoDB stateful set with 3 replicas and the RabbitMQ stateful set with 1 replica. Below that, I verify the persistent volume claims. MongoDB has 3 independent PVCs, 1 for each replica in the replica set, and RabbitMQ has 1 PVC for its message store. This confirms that the application now uses correct Kubernetes storage patterns, 1 persistent volume per pod, managed automatically by the stateful set controller. Finally, I open the storefront application. This is the customer-facing interface used for browsing products and creating new orders. The fact that it loads and connects to the back-end microservices verifies that the entire Pet Store architecture is fully functional. This concludes my Lab 8 demonstration. The system is running end-to-end on Azure Kubernetes Service. Thank you for watching.